Perfect deep inlays. I wanted to take a minute to explain how to get perfect deep inlays with a CNC machine. My name is Corbin Dunn, and I spent a lot of time figuring out how to do this, and I wanted to share my knowledge. I'll talk about when and why to do a deep inlay, discuss some design limitations, talk about feeds and speeds, and then how to find the right parameters to do an inlay. I'll discuss both Fusion 360 and Vectric VCarve, two of the most popular CAM programs for generating toolpaths on a CNC machine. Finally, I'll discuss how to set up your CNC machine for precision in case things aren't turning out just perfect for you. When to do a deep inlay. Now, there are two ways to do a wood inlay. You can do a V-carve with a V-bit like this, or you can do a straight carve with a straight bit like this. V-carve inlays allow you to get a lot of fine detail that you can't get with a straight bit. But one disadvantage is that they aren't very deep, and an inlay would only appear on one side of the wood. So if you want the inlay to appear on both sides of the wood, you have to do a straight bit deep inlay. Another time where you may want to do a deep inlay is if you want to machine away a lot of the wood and have some other shape appear with your inlay inside of it. I use this technique for my hex bowl and also for my concept salad bowl. Proper design. Your 2D vector design has to be machinable with the bit diameter that you're using. So if you're using a 1/8 of an inch diameter bit, you have to make sure all the radiuses in your design are 1/16 of an inch or larger. You also have to make sure all the spaces between your designs are at least 1/8 of an inch or larger. I use Adobe Illustrator for my vector designs, and if you create a new document with inches as your format, you can pretty easily control the radius for all the curves to ensure that everything will be within the confines of your bit diameter. Speeds, feeds, and depth of cut. Speeds and feeds are going to be specific to the machine you're using, but in general you're going to have to go slow in order to get good precision. And specifically, I'm going to be talking about this 1/8 of an inch diameter spiral upcut bit from Amana. And I know if you actually look at this bit, it actually does have a slight taper, but I'm going to ignore that completely. So I cut these inlays at a speed of 14,000 RPM and a feed of 42 inches per minute. This gives a feed per tooth of 0.00075 inches, which is more than Amana recommends. But the thing is you would have to go faster with your spindle speed, and that would leave burning on hardwoods. Or you would have to increase the feed, which would leave a worse finish. So I settled on these numbers by looking at the wood and adjusting the parameters until it looked like a clean cut. For the depth of cut, I use the diameter of the bit, which is 1/8 of an inch. I have cut deeper, mostly by accident, and when that happens, the workpiece will have some wavy edges because the bit will have deflection as it's doing that full depth cut. So in general, you always want to do a step down of 1/8 of an inch or whatever diameter bit you're using. Leave some material. So to quickly talk about some terminology, it should be obvious, but a male plug is the part that fits in to the inlay, and a female pocket is the hole that the plug fits into. On a male plug, it's kind of obvious that you need to leave some material on the bottom, otherwise your design would just fall apart. For a 3/4 of an inch inlay, you're going to want to have at least 1/8 of an inch and up to probably around 1/4 inch of extra material to hold all together. This is like a skin on the bottom. So your 3/4 of an inch inlay is going to need to start from some stock that's probably about 1 inch thick. But one thing that's not obvious is to also leave a skin on the bottom of your female pocket. Now you might have to leave the skin on the bottom just because your design would have some pieces fall out of the female inlay. But the real reason I started doing it is I was starting to get fine cracks when I was doing a through cut. And I found the skin would hold the pieces together and prevent the cracking. I also think that the skin will just help it when you push the parts together and glue up without having any cracks or fractures happening. So for the purposes of this video, I'm going to talk about a 3/4 of an inch deep inlay with a 1/4 inch skin on both the plug and the female pocket. And that means I'm going to need a stock piece that's 1 inch thick. Inlay tolerances. If you make the male plug and the female pocket with 0 tolerance, the two just aren't going to fit together. You can try and force them together, but it will likely crack the wood, either the plug or the pocket or both. However, if your tolerances are too large, you're going to have gappy inlays, and that's just going to look bad. So you have a few choices on how you can make the inlays fit together. You can make the male plug a little bit smaller, or you can make the female pocket a little bit bigger, or you could do both. Now it's much easier to change the tolerance on one of the two and leave the other one consistent, and that way you are doing less work. In general, it's better to make the female pocket a little bit larger. However, you might want to make the male plug a little bit smaller in order to save wood, because usually the male plug, the inlay you're putting in, is the smaller of the two pieces of wood. Take a look at this diagram. If I make the female vector offset, the shape will actually stay the same. But if I were to make the male plug be a little bit smaller, eventually the shape actually starts changing. In practice, you won't ever run into this because mathematically you're going to never offset your design more than your cutter radius. So it doesn't matter if you're making the plug be smaller or the pocket, the female, be larger. Just pick one and be consistent with it. Next, I'm going to talk about how to change the tolerance in both Fusion 360 and Vectric VCarve. You can use the chapters down below to skip the parts that you're not interested in. Here's a quick way to make a male plug and a female pocket. You have a basic sketch, extrude the basic shape 1 inch, create a sketch on the top, import your design, and in this case I use a DXF file exported from Illustrator. Extrude the design by 3/4 of an inch to create the female pocket, hide the body, reshow the design sketch, flip to the bottom, select everything on the sketch, extrude in the other direction, select the opposite parts of the inlay, and extrude 3/4 of an inch. And what this does is it creates a mirror plug to the female pocket. Now my main goal isn't really to teach Fusion 360, but to tell you how to adjust the parameters when you want to do an inlay. So let's jump on to the toolpath generation for the manufacturing tab. So for all machining operations, in general, you're going to want to do a roughing pass and then a finishing pass. I'm going to recommend a 2D pocket for the roughing pass in Fusion 360. 2D adaptive would be faster, but I found that it will generally chip out in wood, and I avoid using that for fine details. To save time, I first like doing a roughing pass with a larger bit, and so in this case, I could select a 1/4 inch bit to remove most of the material. If I do that, I'll repeat the same roughing pass again with an 1/8 of an inch bit to get into the smaller areas. I'll check rust machining and set some parameters that I show here in order to get to cut all the areas that the larger bit missed. For the 2D pocket roughing toolpath, be sure to check multiple depths and to set the depth per pass to be your bit diameter, such as 1/8 of an inch, 0.125 inches. And since this is a roughing pass, I want to leave some material for the finishing pass, and so I check stock to leave and set to be 0.010 of an inch, 0.010. For the finishing pass, I use a 2D contour. I still like to use multiple depths because I found that if I was doing the full depth cut, I would still get some deflection, and the depths help prevent that issue and gave me a better finish. You will sometimes see some little lines from this, but they don't show up in the final piece. I also checked repeat finishing pass, as this seemed to make the fit just be a little bit better and more consistent. So as I mentioned earlier, you have to set a tolerance to cut one of the two a little bit more. And in this case, I'm going to cut the pocket a little bit larger. I set the stock to leave to be a negative amount, such as negative 0.010, 0.010 of an inch. And this causes the tool to cut a little bit more than it should, and this is the tolerance for our fit. I'll talk a little bit more how to dial this in just a bit. The last thing to mention is lead in and lead out. I like to set a lead in, lead out in order to prevent some of the witness marks when the tool enters into the machining operation and exits. I also like to select finishing overlap and set to be about 1/8 of an inch in order to get to overlap a little bit to also remove any of the witness marks. Vectric VCarve. Now I use Vectric a lot for VCarve inlays, but I actually haven't tested it for a straight inlay like this. So a lot of what I'm talking about is just theory, but it all should work because I'm taking the knowledge from Fusion 360 and moving it over to VCarve. First, I'm going to talk about the female pocket. I'll assume you created a new project with the appropriate size, like 5 by 5 inches, 1 inch thick, and you import a vector for the design you want to cut out as an inlay. So in general, for all machining strategies, you're going to want to do a roughing pass, leaving some extra material, and then come back and doing a finish pass to get to the actual depth that you want. In VCarve, I would use a pocket toolpath down to the depth of my inlay, 0.75 inches. Aside from the appropriate speeds and feeds, the most important thing to set is the pocket allowance. And I set it to 0.010 of an inch in this case, and this is just the stock to leave for you to remove during the finishing pass. You also want to make sure that you are limiting the depth of cut to the bit diameter. And in the tool parameters, you can set the pass depth to be the bit diameter, such as 1/8 of an inch in this case. For roughing, I like to use a larger bit to remove most of the material in order to save time. And VCarve makes this really easy to do. You just add an additional bit and set it before your final bit. And in this case, I want the final bit to be 1/8 of an inch, so I could use, say, a 1/4 inch diameter bit to rough out most of the material. Now for the finishing pass, I would select a 2D profile. You want to make sure you're on the inside of the vector. You don't want to be on the vector or outside of it. Just as before, make sure you're doing a depth of cut. That's your bit's diameter, and that way you aren't going to remove too much material. Now either the male plug or the female pocket have to have some tolerance. They have to have a little bit more cutting done to them in order for the pieces to fit together. And in VCarve, you use the allowance offset, and you just set it to a negative value. So in this case for the pocket, I'm setting it to -0.100 of an inch to have it cut a little bit more than it should. And I'll talk about how to exactly find this value in a little bit because it's going to change depending on the wood species and other parameters. So for VCarve, it may not be obvious on how to actually create the plug to have it fit in. So it has to be a mirrored shape. So let's go ahead and select all the vectors. I can copy it. Now I can go and create a new sheet, and I can make it whatever size I want. In this case, it's going to be the same size. I paste the vectors down. I can then go and mirror the vectors horizontally. Then I can create a rectangle vector around the entire workpiece. I can select the rectangle vector and my normal vector design, and then I can create a pocket toolpath that will machine that inner area. Otherwise, everything else is the same as what I mentioned before for the pocket. One other thing to talk about are leads. I do find it good to add some leads. They will help prevent witness marks on the material. So you can experiment with leads if you're actually seeing little witness marks from your bit entering or exiting the material. Test pieces. So the next piece of advice that I would recommend is creating a small test piece with various different values to find the perfect fit. As I mentioned earlier, you can either change the male plug or the female pocket, and in this test case, I'm going to be changing the female pocket sizes. And instead of cutting out my entire vector design, I just picked a small portion of it, and I replicated that portion multiple times on one small board. And then for the finishing toolpath, I set different stock to leave amounts for each one and noted it. I then machined out a male plug, just one of them, and from there I could use this single plug to find out which one would fit in the female the best. If the plug is too loose in all of them, I will make that stock to leave be a little bit smaller or a little bit closer to 0. So if I had it cutting -0.100, I'll try another test piece with -0.005 of an inch and see if it fits better. If it's a little bit too tight, then I'm going to make it bigger. So instead of it being -0.100, I will make it -0.12. So your test piece is going to be rather specific to the machine that you're using, the bit that you're using, and the wood species. So the values may be different for any of those variations and permutations. I also found as I cut more of these inlays with the same bit, the bit starts to wear down, and eventually I will actually have to make the allowance larger as the bit wears down. Glue up. The next thing to talk about is how to squish the two pieces together. I've been putting glue only on the male plug of the inlay. I'll use a small painting brush to kind of get into all the nooks and crannies. Now, since we left a skin on the bottom of the female, I'll also sometimes go and drill holes on the other side, and that way it could let out pressure as I squish the two together. I'm not sure if this is necessary, but I've been doing it, so I'm going to continue to do it. So I found that hammering the plug into the pocket will generally crack the workpiece. And the reason why is it's just impossible to get it to go in perfectly at the right angle. It will always be skewed off to one of the sides, and even if you do get it on or in, it will actually be skewed a little bit and will probably leave a little bit of a gap at that location. I also experiment a lot with trying to clamp the pieces together, and the clamp only really works if the whole clamp fits over your entire workpiece, which probably won't work for anything except the smallest of inlays. In general, with clamps, I had the same problem as hammering. When I would squish one clamp down, I wouldn't be able to get both of them kind of at the same rate and the same pressure, and it just always would end up cracking the wood or not seating all the way in. I could make it looser, but my goal was to have a really tight inlay. So what I found worked best was to use a press. I bought a cheap press from Harbor Freight, and it's been working great for the last project that I did. I can have an incredibly tight inlay, and it seems to squish together without any problems or any cracking. Now the example what I'm doing here is pretty small and fits between my clamp pieces. When I plan on doing a larger piece, my idea is to machine flat some thick pieces of plywood and then squish these two together between the press. That way it will apply even pressure. So your CNC machine has to be really square and true in order to get good deep inlays. If your spindle is tilted to the left, to the right, forwards, or backwards, you're not going to get a good inlay. And I have a video that I'll link to on how to tram your spindle and how to check it and make sure it's perfectly straight. So check that out if you are having problems, because maybe your spindle isn't trammed right. Another thing that's good to test is to make sure that your machine can cut an appropriate size. So you can cut a square of a known distance. The larger it is, the better it'll be for this test. And you can measure both the X and the Y axis to make sure that they're the same. As long as they're the same, you're probably going to be good. They might not be the exact measurements of your square. So if you try to cut a 10-inch square and it's a little bit bigger or a little bit smaller, that's probably due to other reasons, such as the actual diameter of the bit. I wouldn't worry about that. The most important thing is that the X size matches the Y size. And if they don't, you have to figure out how to adjust the steps on your machine until they're accurate. The next thing to test on your machine is to make sure that your bits have very little run out. So you can test for run out by using a dial indicator and putting it up against your bit, spin your bit manually by hand, and seeing if the indicator moves. If the indicator moves a lot, really you want it to be about 0, but if it moves 0.02 of an inch, that might be too much for getting good accuracy. Things that you can do to remedy this: you can ensure you're using high quality collets. If you're using a cheap collet, then the collet itself may have the run out and be causing you a problem. Generally, for very small bits, you want to have very little run out, and so use good collets for small bits. You could use cheaper collets for bigger bits because it won't affect it as much. If you are getting run out, even with a good collet, you can try loosening the bit and rotating it, say 45 degrees, testing for run out, and repeat that process until the run out is minimized. Now the run out might change every time you swap a bit if you're doing manual tool changes. So another way to have very good consistency is to use an automatic tool changer or ATC. However, I know they're really expensive and not everyone may have one. So that's it. Hopefully this video helped you figure out how to do deep inlays, and I made this video just to share the information, but also to remind myself so that in the future when I go and try and do another deep inlay, I can refer to this video and figure out what I did. Thanks everyone.